Welcome to EDU World Space.
The Fibonacci sequence is given below. So recall, it's defined by starting out with 1, then you have 1 after that, and then the next term you obtain by adding the previous 2 terms. So the third term would be the sum of the previous 2 terms, which is 2. Then you would add the previous 2, and so on. Okay, and so that's all right there. That's a sum of the sequence. So for part A, well, for here we have 3 identities, and hopefully we could use part A to do B and C. So first, let's start off with part A there. Let's just show that this is true. So personally, I don't like those denominators, so I'll go ahead and multiply both sides by that denominator on the left, just to get that out of there. Then on the left side, we just have 1. And on the right-hand side, when we multiply, and then simplify a little bit there. So let me show my work. So let me go a few steps back here. We have this is after multiplying both sides by the denominator on the left. So then we have this. Cancel as much as we can here. Cancel those fn minus 1s. Fn plus 1 over here. And then we're left with fn plus 1 over fn minus fn minus 1 over fn. So we could put these together here. So or in this case, actually, let's just multiply both sides by fn. First, I'll just get that common denominator. So we have 1 over here, this on the far right. Multiply the fn to the other side. And then finally, add this blue term to the other side. And then we have fn minus 1 plus fn equals fn plus 1. And this is true based on the definition over here. So this is true statement. These are both true. And this verifies part A. So we can rewrite this fraction in part A on the left using the decomposition on the right. And then we'll use that in parts B and C. So for part B, let's go ahead and start on the next page. So we're on part B here. We're summing from 2 to infinity, 1 over fn minus 1, n plus 1. And we would like to show that this equals 1. So first, let's recall the formula. So this, or let's just use part A right now. So this is using part A right here. I'll go ahead and replace the fraction with the decomposition. So we have 1 over fn minus 1 fn minus 1 over fn plus 1. This is just from part A. We just showed this a few moments ago. Now let's do the telescoping. So first, I'll rewrite this as a limit as k goes to infinity, and then I'll look at the partial sum from some number from 2 up to some number k. So we'll evaluate the sum, and then at the very end, we'll come in here and take the limit. So let's go ahead and now this is where we're setting up the telescoping. So plug in 2 first. So that's the first term when you plug in n equals 2. Then plug in n equals 3. and so on, and I would keep going, and then I get to the second to last term when I plug in k minus 1 for n. And then I would add the final term in when I plug in n equals k. This is 1 over f k minus 1 fk minus 1 over fk, then fk plus 1. Now we telescope and cancel as much as we can. So we see that the first term will never cancel because none of the other denominators have f1. However, f2, f3, we have cancellation, and we'll continue to have cancellation all the way up until we get to this k minus 1 fk, but then we're left with one more term out here that will not cancel. So the next thing to do here is just to evaluate this. So let's just go ahead and write this on the next page and then take that limit. So I'm out of room here, so I have 1 over f1 f2 minus 1 over fk plus 1, and we're taking the limit as k goes to infinity. Now as k goes to infinity, this is just constant here, and we know that f1 equals 1 and f2 equals 1, so we just have 1 over 1 there. But since these terms are both going to infinity and they're in the denominator, so we're using the fact here that the Fibonacci's numbers do go to infinity. The denominator goes to infinity, so the fraction as a whole is closer to 0. Therefore, the entire sum is just 1, and that is exactly what we wanted to show for part B. We wanted to show that the sum was equal to 1. Now, finally, let's also look at part C. So let me go to the next page here. For part C, we are looking at the sum, very similar looking sum, but this time we have Fn in the numerator. And we'd like to simplify this and eventually show that this should equal 2 when we're done. So here we could try to use the formula that we had from part A. So from part A we had but we also have this Fn in the numerator now. So let's just introduce that Fn over here by multiplying it up top. So this is what we have on the left. It's the same as the fraction over here on the left. And then after we simplify over here, cancel those Fn's, we have 1 over Fn minus 1 minus 1 over Fn plus 1. And so this is what we can do when we replace the sum here. So now we have the sum going from n equals 2 to infinity, and now we have 1 over Fn minus 1 minus 1 over Fn plus 1. So that's just using part A. Once again, as I mentioned, we were going to use part A for part B and C. So now we'll set up the telescoping again. So telescope. So first, I'll rewrite that infinite sum as a limit. And then instead of doing the whole sum, I just look at the partial sum. And then I just keep this the same. Here's my AN. Now let's expand this sum, and then we'll do our telescope. So start the adding by plugging in n equals 2. So 1 over f1 minus 1 over f3. And then 1 over f2 minus 1 over f4. Plus 1 over f3 minus 1 over f5. And so on. And then we would have to also add the last few terms. So I'll add 3 more terms in over here on the right end. So the very last term is when you plug in k. Before that, you plug in k minus 1. And before that, you plug in k minus 2. And so here, what's our formula? So we would have minus 1 there. So then let's try to see if we could cancel out as much as possible. So F1 and F2, these won't cancel because the negatives start at F3. So we'll still have 1 over F1 and we'll still have 1 over F2. However, once we get to F3, we see that we'll start having some cancellation here. That'll cancel with that. And this negative 1, 4 will also cancel if I keep adding terms. On the other hand, let's look on the other side, the far right. This term will not be canceled out because if you look at the positive fractions on the left of all the parentheses, the farthest they go up to is k minus 1. So we'll be able to cancel these out up to k minus 1, but unfortunately the minus 1 over fk and 1 over fk plus 1, those will still appear. So let's go to the next page to write this out. And we're still taking the limit as k goes to infinity. So now let's take that limit, since as we noted in part B, fk goes to infinity. Fibonacci numbers do continue to grow without bound. That means that these denominators both go to infinity, so the fractions as a whole will go to 0 in the limit. We're just left over with 1 over f1 plus 1 over f2. But recall, by definition, f1 and f2 are both equal to 1. So we just have 1 plus 1 equals 2, and that's exactly the sum that we wanted for part C. So there's our final answer.